Welcome to the Deep Dive, your shortcut to being well-informed. We try to pack in surprising facts and hopefully just enough humor to keep you hooked. Today, we're really diving headfirst into JavaScript and Node.js, specifically how this powerhouse duo helps us build, really scalable server-side applications. Our mission today, we're going to unpack an InfoWorld article by Matthew Tyson. It highlights 10 really crucial JavaScript concepts you absolutely need to get right if you want to succeed with Node.js. Now, look, whether you're already architecting big systems or maybe just dipping your toes into backend development, we want to cut through the noise here, deliver some actionable, memorable insights. Tyson makes a great point. JavaScript is incredibly versatile, sure, but that versatility, it can be a bit of a double-edged sword. Its flexibility is powerful, yeah, but it puts the burden of structure, of maintainability, kind of squarely on you, the developer. So our goal today is simple. Make sure that sword is working for you.
Okay, let's unpack this. First up, one of Node's, core superpowers. How JavaScript enables these non-blocking operations. This isn't just jargon. It means you can tell the platform, hey, start these tasks without waiting for each one to finish before starting the next. It's kind of like a chef prepping multiple things at once, right? Not waiting for the oven before chopping the veggies.
Exactly. And what's really fundamental to that superpower is how Node handles asynchronous operations. We mainly talk about promises and async await here. Think of promises as placeholders. They represent a value you don't have yet, but you will eventually. They give you a standard way to handle success or failure later on. You'll commonly see then used for success and .catch for errors. It makes the flow pretty readable. For instance, reading a file might look something like fs.readFile, file path utf-8 dot, then file data do stuff.catch error, hack attach. Makes sense. Yeah, that chaining makes it clear.
Right. Then you've got async await. This is, well, basically it's syntactic sugar built right on top of promises. The key idea lets you write asynchronous code that looks and reads almost like synchronous code. Which is huge for readability, especially with sequential async steps. You just mark a function with async, then use await before any call that returns a promise, like async function read file async, const file data, await fs.readFile, file path hef, a process data. Yeah, you get all the non-blocking benefits, but without getting tangled in, nested callbacks.
That's amazing how async await cleans things up, makes it look so linear. But, okay, here's where it gets really interesting for me. Node.js is single-threaded, right?
Yeah.
So how does it do all this non-blocking stuff? How does it seem like it's doing things concurrently if it's not actually juggling multiple threads of our code? What's the magic behind the curtain?
Yeah, that's a critical question. And the answer is the event loop. That single-threaded event loop is precisely why Node shines for I/O tasks. It's concurrency model, not really a limitation. The absolute key takeaway here is never block the event loop. Don't run long, synchronous, CPU-heavy calculations directly in your main node thread, because anything that hogs the CPU and doesn't let the event loop cycle back will just grind your whole application to a halt. Total unresponsiveness.
Okay, so how does it work then with something like a database query?
Right. So when you start an async operation, like that database query or maybe a fetch call to some API, Node essentially hands it off. It tells the underlying operating system, hey, handle this. And crucially, the event loop is now free. It doesn't wait. It goes off and processes other requests, other events. Then, when the database finally responds or the API call finishes, the OS notifies Node. The event loop sees this notification and says, okay, I have the result, and then it executes the callback you provided, like your .then handler, when it gets a chance. This whole mechanism lets Node handle, thousands of connections efficiently. It just keeps switching between tasks without getting stuck waiting for slow things.
That's a really clear way to picture it. Thanks. Okay, so we understand the async core now, but as projects get bigger than just one file, complexity obviously shoots up. How do developers actually organize all this code effectively? Keep it maintainable, scalable, stop it from becoming this tangled mess?
That is exactly the job of modules. Modules are JavaScript's way of breaking code into logical, reusable pieces. They let you encapsulate functionality, avoid name clashes, and control what gets exposed. You see it everywhere, like importing built-in Node stuff. Import fs from f's promises, or pulling in your own helper functions. Import from .util's MJS.
Right, imports and exports.
Exactly. Use export for name things you want to share, or export default for the main thing from a file. Now, the modern standard is ESM, that's ECMAScript modules with import-export. But you'll definitely still see the older common JS style require module.exports in a lot of Node code out there. Right. Doesn't matter which syntax, really. The principle is solid. Breaking software into focused components is absolutely fundamental for managing complexity. especially on bigger teams.
Okay, modules help organize, but sometimes these pieces of code need to remember things from where they were created, right? Like configuration or some initial state. How do they hang on to that context?
Ah, that leads us beautifully into closures and scope. This is a profound concept, actually. A closure, at its heart, means a function remembers the environment, the variables around it where it was created. This is often called its lexical scope, and it remembers this environment even after the code that created it has finished running.
Okay, can you give an example?
Sure, the article's Abbey Road example is perfect. Imagine a function setup ranker that declares let album Abbey Road inside it. Then inside setup ranker, you define another function, say rank, and setup ranker returns this rank function. That inner rank function forms a closure over the album variable. So even after setup ranker has finished and its local variable should be gone, rank still has access to album. It remembers Abbey Road.
Wow, okay, so it holds on to that variable.
Precisely. It's not just a neat trick. Closures are fundamental to so many patterns in JavaScript and Node, especially in functional programming. They're key for things like private data encapsulation, too.
That's powerful. So closures handle function context. What about bringing data and the behavior that acts on that data together? More like, traditional object-oriented programming.
Yeah, for that, we typically turn to classes. Modern JavaScript gives us a really clean class-based syntax for defining object blueprints. Now, technically, under the hood, it's still prototype-based inheritance, but the class syntax is much more familiar to many developers. Classes are great for encapsulating or bundling related data properties and behavior methods into one unit. Think about the album class example. It defines properties like title, maybe a private hashtag track list. Then methods like add track or display album info operate on that data. You can even have static methods like get genre category that belong to the class itself, not individual album instances. It's a powerful way to model things.
Classes definitely offer that structure, but I have heard some folks argue, especially with functional programming getting more popular in JS, that classes can sometimes feel a bit rigid or cause confusion over this keyword. Do you think that usefulness diminishes in Node, or are they still a solid choice for bigger apps?
That's a really valid point, and yeah, it's often debated. Classes are fantastic for modeling domains with clear structures, like you said, encapsulating state. But sure, there are times when a more functional approach, just composing functions, might feel lighter, especially for utilities or simple data flows. The rigid critique sometimes comes from trying to force complex inheritance hierarchies onto JavaScript, which isn't always the best fit. However, for building serious server-side apps, things like API controllers, service layers, data models, classes are still incredibly useful. They help with patterns like dependency injection, they organize related logic clearly. So yeah, they're a fundamental tool. Knowing when and how to use them effectively is the key.
That makes sense. It's about choosing the right tool. Okay, moving on from code structure. Once we have our application organized, how does data actually flow efficiently within the app, between different parts, or even out to other services?
Right, and connecting this back to performance, streams are absolutely vital here. Streams are Node's built-in way to handle data flows, network requests, files, WebSockets, whatever, as a sequence of chunks or events. Instead of loading, say, a massive file entirely into memory first, which is often impossible.
Yeah, I think we've all been there.
Right. That dreaded out-of-memory error loading a giant CSV or something. Definitely no bueno, as the article says. Streams let you process data as it arrives. They emit events, like data when a chunk is ready and when it's all done, or error if something breaks. So using something like fs.create-a-read-stream lets you process a huge file piece by piece. You attach doc callbacks to handle those events. Your app stays responsive, uses way less memory. Critical stuff.
That real-world example nails it. Streams are essential for efficiency. And when data is flowing, especially between different systems or applications, what's the standard format or the common language?
Oh, that's definitely JSON JavaScript object notation. Its structure seems simple, right? Just name value pairs, curly braces, square brackets for arrays. But its real power is its universality. Everyone uses it. Pretty much. It's human readable, machine parsable, and totally language agnostic. That makes it the lingua franca for data exchange. Web APIs, config files, NoSQL databases. It's everywhere. And JavaScript naturally makes it super easy. You have the global JSON stringify to turn a JavaScript object into a JSON string.
To send over the network, for example.
Exactly. And JSON.parse to take an incoming JSON string and turn it back into a usable JavaScript object. It's just the standard way to shuttle data around in modern development.
Okay, so we've got modules, classes, streams, JSON, building blocks, and data formats. But nobody builds complex apps entirely from scratch. Where do all the external libraries, the tools, the utilities come from? How does that ecosystem work?
Yeah, that's where NPM, the Node Package Manager, is absolutely central. NPM isn't just a tool to install stuff. It's the gateway to this vast ecosystem of open source JavaScript code.
Mm.
Anything you can think of, pretty much there's probably an NPM package for it. Data handling, authentication, database drivers, testing tools.
It's huge.
It really is. So when you build a Node app, you define all the external libraries your project needs, your dependencies, in a file called package.json. Then you just run npm install, and npm fetches all those packages and puts them in a Node modules folder ready for you to import in your code. But package.json does more too. You define scripts and their shortcuts for running common tasks, like starting your server or running tests. And it's where you'd set things like type.module if you want your project to use ESM by default. So yeah, you could say the insides of your Node app are JavaScript, but the outsides managing all the tooling and libraries, that's all NPM. It's a cornerstone.
Indispensable, for sure. Okay, so we have all these powerful tools, great organization, efficient data flow, but things still break, right? Stuff goes wrong. How do we build apps that are robust, that can handle errors gracefully?
Ah, yes, error handling. Crucial, but sometimes an afterthought until, well, things blow up. In Node, you're mostly dealing with two kinds of errors, regular runtime errors and asynchronous errors. For synchronous code, and also inside async await functions, you use the standard try-catch blocks. You put the code that might fail in the try part.
The risky bit.
Exactly. If an error happens there, the code execution jumps immediately to the catch block. That's your chance to handle it, log it, maybe send an error response, try to recover. For promises that aren't wrapped in async await, you handle errors using that .catch method chained onto the promise.
Okay, so different mechanisms depending on the context.
Right. But the core idea is the same.
Yeah.
Expect things to fail sometimes. Good error handling aims to, if possible, recover. If not, minimize the pain for the user, definitely log the error so you can fix it later, and maybe return a clear error status if it's an API. And one big warning, never just swallow errors. Don't write an empty catch block that does nothing.
That just hides the problem, right?
Precisely. It leads to silent failures that are incredibly hard to debug later. It's like ignoring a warning light in your car. Not a good strategy.
Definitely not. Okay, so we've covered a lot of ground. Asynchronous foundations, organizing code, data flow, the ecosystem, handling errors. What does this all mean for us as developers? We started by saying JavaScript's flexibility is this double-edged sword. How do we pull it all together and use that flexibility well?
Well, what's really quite cool about JavaScript, especially with Node, is how it genuinely supports so many different ways of programming. Functional, object-oriented, reactive, even just plain imperative style. This flexibility means you can pick the right approach for the specific problem or even blend styles within the same application. But it also leads to that common feeling, there's more than one way to do it. And you start wondering, is this the best way? Is there some newer, cooler technique I should be using?
Yeah, that constant question.
Yeah.
Totally normal. I think the real trick is finding a balance. You have to deliver the work that needs doing now, using the tools and patterns you know well. But also make time. Commit to continuously learning, researching new patterns, trying out new libraries, understanding the trade-offs. As you get deeper into these core concepts we talked about, you'll naturally start to get a better feel for when to use classes, when functional programming fits better, when streams are essential. Being a master programmer isn't really about knowing every single thing. It's more like being a master musician or martial artist. It's about continuous learning, adapting, knowing how to choose and apply the right technique. So the philosophy becomes something like, okay, this is the best approach I know right now for this problem, and I'm committed to getting better, to improving my craft.
That's a great way to frame it. And that really wraps up our deep dive into these 10 essential JavaScript concepts for Node.js. We've gone from async ops and the event loop, through structuring code with modules and classes, managing data with streams and JSON, leveraging NPM, and finally, robust error handling. Understanding these isn't just about writing code that works, it's about building applications that are scalable, resilient, maintainable, apps that can really grow and adapt.
Absolutely. And like any deep skill, mastery is a journey, not a destination. There's always more to learn, another layer to uncover, especially in a field moving as fast as server-side JavaScript. So maybe the final thought to leave you with is this. Now that you've got a firmer grasp on these foundational concepts, what's next for you? What new paradigm, what interesting tool, or maybe what best practice in the JavaScript and Node world are you inspired to explore now, to push your own understanding and mastery just that little bit further?